Hello and welcome back to Compiler Programming. We are continuing to work on the custom operator support, and with named return values out of the way in the previous video, I'm ready to jump to defining a new operator. This is not going to be finished today in a full feature set, but we should get something working. First thing is to try to figure out what syntax would be nice for this to have, and then I guess we need to implement it. I will start with the infix operators, so something like what you would use for a plus, and the operator I have in mind is not very useful maybe directly, but it will be nice to have eventually, and it's also a good test case. So it should be possible to define infix operators. Okay, and this is what I have in mind. I think actually the first test case that we will do, we will just alias plus, and we will have another operator that will be exactly the same as the plus. I think we can do, I don't know, well, let's call it plus plus, and it will not be like this. We will change probably how this is done. We would say operator plus plus, and so there are several things that we need to do to be able to define an operator. And the first thing is obviously the actual symbol that we're going to use, right? Then we need to know if the operator is infix or prefix or postfix. So is it something that requires like two things in the middle here, or is it something that requires just one? So for example, if we can do maybe postfix plus plus. Let's work on that one. So that would be a postfix, right? So it has one thing before it, and then the operator itself. We also need to know the precedence of that operator, and so I guess I will need to do something like operator, I don't know, 18 or whatever, 10. Then we say, well, maybe I will put this in braces. That seems reasonable. And we can put an identifier here. And the final thing that we need is actually like what we're gonna do when the operator is matched. And I think I want to make it in the same way as the macro that this is. Yeah, this is just going to expand to a particular macro. So it will use exactly the same functionality underneath, I think. And I hope that will actually work. We will see if I'm correct or not. Maybe best if it's not really a macro style, but more like an inline function. But regardless, let's say that we will have a function called increment, and we'll just say increment of x. Or alternatively, if we keep it as a macro, then we can make it better. We say, so this is in C terms, this is a post increment. So that means that we get the value, we store the value in temporary place, then we actually get the we store the value, then we increment it, and then we return the value. So something like this. We have x, we say, I don't know, y is x, and then we say x is x plus 1, and we have y. So this is what plus plus does. In our current implementation, because of the lack of optimizations and other kind of things, this will actually be pretty terrible. Like this, every plus plus will incur stack allocation. So let's actually switch it to a prefix one. At least that one is pretty reasonable. We say that x is x plus 1, and we will do x. Okay, I'm pretty happy with that. Now we can do a function, so we will call it, I don't know, main, whatever. And this function will return to us a 64. One advantage of doing it as a macro means that we will not have to specify multiple this is a very generic way to define this. There are no types here or anything, as long as the type has like the type has a plus operation, then everything is fine. This, I mean, in C++ and in modern C++, you would use something like concepts, I guess, that will give you the same functionality, but we will stick with this version for now. And we just say that, I don't know, x, let's use a different variable name just to be sure that we are fine. Y is 41, we say plus plus y, and we are going to do y. Something like that. Okay, main, checker, yeah, I think I like this version more. Something like this. Okay, so that's our test. And this is roughly the syntax that we will use for this. Actually, I forgot to do a semicolon here. Yeah, and we are ready to try it. Obviously, it will not work, but we can go from there. Yeah, we have an error. It says could not parse top-level statement at the line 1 and 0. So it says I have no idea what to do with this stuff, but it's very true. So let's go from there. We have this could not parse statement, right? And we will copy parse syntax definition, and we say parse operator definition. Okay, this is our syntax definition. That's quite a lengthy function. So we will copy that. If we can later make it better and reuse some code, that's great. If we can't, that's also fine. Parse operator definition. Okay, this makes sense. We have operator and okay. So I can say maybe match precedence. So yeah, parsing of this one is a bit tricky because maybe I want precedence to be optional. Actually, no. Okay, precedence, and actually don't care what it is. And then I would have a pattern, yes. Okay. Okay, so this is fine. I will fill in user errors later. And then replacement, that also is fine. This is definition. This is exactly the same as it was there. Okay. I guess one thing we need to do is to say value star precedence. Let's call it precedence token. Precedence is we need to actually extract the numeric value from it. So token force constant value. Is that the correct function? Let's check. Yeah, that seems to be correct. So we can use that. I should have checked. Okay, just takes the context and the token. Great. So context and precedence token. Okay. If there is no precedence, then we fail. Or precedence descriptor is unsigned integer. So we expect it to be an integer that we can use. Now we say use 64 precedence. And this would be operand. Actually, here we need to say another one. So we assert that operand is immediate of precedence value operand. This is an assertion and will not be a user error because if we use the constant evaluation here, we actually expect it to be an immediate because everything is constant, so it should be available to us right away. And if you don't get that, that means something went wrong. Operand immediate memory as what is the actual thing that I want to use? Let me check. Operand immediate memory as this is like up to yeah, this is what I want. Okay. D64 from this thing. Okay. What do I use for operators? Copy operator precedence. This is signed. This doesn't make sense that it's signed. Yeah, it was because I was using it. I had a sentinel value there, but doesn't exist anymore. So it makes sense that this is an unassigned one. Okay, we have it here. So now we have the precedence. We get the pattern token. Great. What else? So now we have the replacement and we have the definition. That's great. This doesn't exist. And we also don't want the pattern. Yeah, the parsing will be slightly different from the macro case because I don't want, at least for now, an arbitrary version of this. All I want is to be able to define prefix, postfix, and infix operator. Like, for example, I don't want the situation that operator suddenly takes two things on the right-hand side. Like, this is not It's just not what I want at the moment. Maybe we will allow this eventually, because that's, for example, something that a function does, right? It has on the left hand side mm, the arguments, on the right hand side is return types, and then another thing on the right hand side is sort of the body of the function. But for now, we're going to treat it as a special case and not going to do it. So for now, we'll just expect basically an operator to have either 2 or 3 values and nothing else. So let's verify that. So we say switch, or actually I will do it with an if, it will be a bit nicer to look at. So if definition length is 2, else if definition length is 3, else panic. Okay. So this is gonna be prefix and postfix, and this is infix. Okay. Now we need to extract things, so let's do that. Here I'm gonna say the following: if const. Okay, if token view get definition 0 tag is token view token tag operator is actually no, this is gonna be postfix. So if if the first one in the pattern here is an operator, that means it's a postfix one, right? So we can say if is postfix. Right now I actually don't distinguish type of the operator here, and that might be a problem, because the parser currently does not care about that. Yeah, that's gonna be problematic, I think. So let's actually create the type of the operator, and then we'll figure out how to best deal with this. Then I might not even need argument count, to be honest, and that will be replaced by the type of the operator. Yeah, let's so I'll bring this in, and then we will figure out how to do it. Operator type, very generic name, but okay. I don't know what is the common name for the infix, postfix, and so on. Operator, infix, postfix, name. I don't know. How is it called? Because it's not precedence. I don't know. Fixity? Is it even the thing? Is it? I guess that's the correct name. It's called also associativity here. Right associative, left associative, but that's not exactly the case. So yeah, I also will need to have associativity there. Yikes. Okay. Whatever. I will call it fixity. I don't know if it's correct thing. So operator prefix, prefix, postfix. Actually, it's suffix, I guess, and infix. Actually, it's called postfix here as well. Why isn't it called suffix? Okay. Well, postfix. I like postfix more. Okay. Have a bunch of errors. Let's see how they are. Okay. Is postfix? No, so I will say operator fixity is infix, and maybe actually that should be the default one. Okay. Then actually maybe I won't use it that way. Okay, let's leave it like this. Is postfix. Okay, so we'll need to do stuff. First, we need to say that const token star argument is, what is it? It's token you get definition one. So the next thing is supposed to be an argument. We can verify that if argument actually wait, this is actually is prefix. I'm wrong. Yeah, argument tag is not token tag ID. Then we panic, and else we panic to do not implemented postfix operator and not implemented infix operator. Okay. These ones we can actually already put in the right places. Fixity, not postfix. I misspelled postfix here. Okay, so we got to here, I guess. We are not going to create a macro. So all of that actually needs to go away. I will leave this for now like this. Actually, since there is no error handling yet, I will not even include it. We have this, we have an operator, we have this stuff, and I guess I can also do to do check already defined one. So I think unlike functions, I will. Do I want to support operator overloading? That is a very interesting question. Maybe, I don't know. I guess. I mean, one way to support this would be what I'm doing right now, where the actual operator is not overloadable, but whatever expression you can put in here, right? You can put a function call in here, and then that function call is perfectly overloadable. So I don't know. I need to think about it. I need to try out a few different things. For now, it doesn't really matter. I will keep it not overloadable. Check already defined operator. In scope, as we do not allow overloading. And with overloading, there is also a question about it being prefix, postfix, because I definitely don't want to allow. Well, I was thinking that I don't want to allow to overload on the um, like have the same thing prefix and postfix, but that's sort of how plus plus works, and that is also how unary minus works. So I guess that needs to be a thing. Like as long as yeah, if as long as the precedence is not the same, it should be perfectly fine to overload them. But that will need some changes from how operators are stored at the moment, because they are not ready for that. Anyhow, let's continue. So we have this stuff. Okay. Precedence value. Misspell that as well. Local is not referenced. That's fine. I actually wanted to do this. Okay, so we are building again. We will still have obviously an error because we only defined this thing, or we not defined, we only parsed it. Now we have a known operator plus plus as the error, which is a good error to have. That means that the rest of the compiler is working as it's supposed to. It even points us to the right thing. I'm not sure 67 seems a bit too far in the... Yeah, I think there is a screw up here with the lines, or with the column count, but I can check this out later. Okay, getting back to this. We need to define an operator. That should be pretty straightforward. We have a bunch of them here. Operator, yep. So this is what it will look like. And I think we will need to have a handler one. Okay. I'm not sure if it's a good idea to define it like this. Actually, probably we don't need it. Because we will do the checking and putting it in here. Okay. So we will just get it. And this const token star first, source. Okay. We will define them in the current scope. Operator precedence, we have that. Argument count is 1. Fixity is this thing. The only thing that we are missing actually right now is the handler, so I will remove it. And that would mean that we will get a new error, I think. Actually, we should get an assertion now, because you're not supposed to get an operator without a handler that is also not manually defined in our handling code. Okay. So that seems fine. Let's try to run this. Yeah. Okay. As expected, now we have actually an assertion. So that means that we correctly define an operator. Oh, these ones don't even have. Okay. Gotcha. So now the funky part, which I'm not actually certain how to handle well. We need to provide a handler. And handler is gonna be more or less the same thing as the macro, but not exactly. So this is essentially a funky way to define a macro. Do I want to use that mechanic somehow? I guess. Okay. So let's say token handle user defined operator. And I will look at token handle negation. So this is our handler we have for the only dynamic dispatch operator that we added a couple of videos ago. Okay, so now we will actually need a payload for our handling, but we will see what it needs to be. Let's just start writing this and then we will get to understand what we actually need. Okay. So we get this stuff. We don't need to assert here yet. We have the view. So this is our arguments. Okay. Okay. I'll leave it as a view, but it's actually let's do it like this maybe. Yeah, okay. Arguments, what am I doing here? I'm just doing a constant evaluation, which is interesting, but okay. And then I do stuff. Okay. So that is the default implementation, but I want to do something else. I want to let's get back here and actually look at the macro. So we have pattern, a macro pattern. So this is matching stuff. Okay, but that's not exactly what I want. Token macro, is it not called like that? Token replace parse macros. Okay, let's go in here. Token match pattern. No, we don't want to match, but I think we do want this stuff. Parse macro match. Okay. This is, so it gets in a view that is a match and gets in a macro. It defines these things and then it applies the replacement. Okay. Does this make sense? Maybe I don't actually want. Yeah, I think I don't want the macro version of this. I think what I want instead is the function call. And in particular, I want to have the version of the function call that deals with the macro stuff. Yeah. So basically this stuff here. This is what I want to do. Okay, I'm just gonna grab this stuff and we will go from there. So we need to have a scope, which we don't have. And we also need to, okay, this defines arguments. That means we need to store them somewhere. A return value, result value, that is not really a thing. Yeah, I think I will then need to do quite a few changes, but for now we'll just hack something in to make this stuff work. Okay, back to the definition. Actually, now that I'm looking at this, this needs to go way up in the file. It needs to be before here. Or maybe not. Okay, let's see. So we need to have IDs for the arguments. Okay, let's store them, I guess. Let's create a type def struct user defined operator. Okay, what do you need to have? You need to have arguments, so that would be array slice argument names, and then Actually, I will not even do arrays. I will just say I slice argument 1, argument 2, like this. But because for now we can only have 2 arguments, that is actually easier to deal with. And then having arrays, or to be more C-ish, we say arg0 and arg1. Okay, what else? Well, we need to actually have that body, right? So that is going to be token view body, I guess. That seems fine. Here we need to add another thing, void star handler payload, and where we call the handler, we need to pass on that payload. So handler handle operator, handler and dispatch proc, dispatch constant operator, and dispatch operator. Yes, in here, instead of 0, what we need to do is to say operator entry payload. It's called handler payload. Okay, it's fine. Handler payload is not a member of operator stack entry. That's because it needs to be in the scope entry. Yeah. Okay, so now we are passing that thing by, but we still need to create it here. So this is that user defined operator. Actually, it also needs to know argument count or fixity, I guess. This is a bit redundant, but it's fine. Because from the standpoint of the entry handler, this payload is a peg, so we shouldn't look into it. So if we need to put it both in the payload and for the operator parsing, then that's okay. Operator, we actually need to allocate it. Context allocator, user defined operator, star operator is this fixity is this stuff, and then we need to say argument arg0 is our argument source, and body is, we actually need to capture the context as well. So compilation context, actually let's put the several things. So we have a scope. Do we need anything else? Well, let's start with what we know we need. We definitely need scope. So body is the replacement. Let's call it body in both cases. and scope is context scope. Okay, I created it. This needs to be a star. And we're gonna pass this as handler payload. Like so. Okay, we can get back to our handler. So now we can say user defined operator and then make it necessary based on the functional origin functions parent scope. Why do we use function parent scope, not the actual scope? But okay, I think here it should be like this. Okay, switch on operator fixity, case operator fixity infix break panic to do not implemented infix operator. Okay, and we have prefix and we have postfix. So this is where we will actually work now. We have define value, body scope, that's good. Arg name, that would be operator arg0, and arg value, yeah, so arg value, value star. This is not great, but I will think about how to handle it later. So arg value is token force value. Yeah, something like this. Context args. So here we can actually assert that args length is 1. We need to get it. Token get args 0 and arg value. Is that all? Yes. Yeah, I think that's fine. For the argument, we need to evaluate it in the context of the outer thing, which is inside right now. This one, okay, so that's fine. We define that thing here. It's a postfix and not a postfizz. Postfix, okay. This seems pretty stupid. I don't know what it was doing before, but okay. And this is dealing with return stuff. Well, okay. And token body. So here we are cloning the token. Uh-huh. Yeah, so this expects the body to always be a curly thing, and I think for now I will just let it be. What I will do is I will say body token curly, and I will change this to be const token star body. Eventually I want it to be an arbitrary thing, but for now it's just this is easier this way. Okay, body token body. This was context. Oops. Okay, so we'll get our token, and that means I can do operator body. Okay, what happens now? Now I need a body context. Yeah, okay. And actually here's just the result value that is problematic. And finally here, target token, source range. Okay. So we don't know. We need the range for the outer thing. Okay. Mm. Let me get the source range of the call. Operator application. Body token undeclared identifier. And that is because it's operator. And it's not body token, it's body. Okay. So we've done all of that stuff. Now we just need to say return token value make context and result value. Is that all I need to pass? No. What else do I need? I need the range. Okay. We can give you a range and it's the same problem. Source range star range or call range. Okay. Okay, we are building again. that is progress, but I have no idea if this is even remotely what we want. So I will actually open up the debugger right away and look at what is happening inside handle user defined operator. So let's break over here and run. Okay, we got to here. That is already good. Let's look at what we have. We have correct fixity. We have argument that is x. We have the body. Okay. And we have a scope. Do we have a scope? Yes, we actually have a scope. That is a global scope. Well, everything seems fine here. Let's see if that still works. We have one argument. We have it here. Now we try to force it. Let's see if that will work. Well, we have something pretty reasonable, I'd say. Okay. We define the value. We go from here. This is the return stuff. That's not important for now. And we have the body. We create the context. Now this moment of truth, whether this will actually do what we want. Actually, yeah, that's fine. Well, result value seems reasonable as well. Yeah, all of that seems pretty reasonable, I guess. Let's get back to the test and try to step here. Run to cursor. Okay, checker. Look at that. We have it working. Great. And continue. Let's run the test here. Everything else still works. We have our prefix operator working great. Yeah, I don't think I will do the rest of this stuff on the video because there's just more of the same. I will have to do the same for postfix. I will have to do the same for prefix. I need to figure out where to get the source range. All of it is very important for the quality of life of the user later on, but it's not very interesting to watch the same thing over and over. So for today, that will be all. Thank you very much for watching and hopefully see you next time.